Hello, my name is Joe Blackett. I'm a student at University of Cincinnati. This is the IT graduate seminar class. So this is my presentation on future impact of blockchain. I want to start with Bitcoin because most people haven't heard of blockchain or don't even know what it is, but they have heard of Bitcoin, and it's especially relevant because this week Bitcoin surpassed $10,000 of value for one Bitcoin. So people trade in 0.001 of Bitcoins to do transactions. And if you have one full Bitcoin, then it's actually worth $10,000. It's pretty interesting. So what is Bitcoin? Bitcoin is an open source peer-to-peer digital currency, world's first completely decentralized digital payment system. So I'm going to go over some concepts of this just because they're important to help understand what blockchain is. So what is decentralized? So a centralized system has a central bank. In the case of a currency, it would be a bank. And decentralized would be there is no central bank. So I've got, your standard network maps down here. We've got a centralized network, which is most computer networks are going through some sort of server that's handling everything and making sure everybody has the same data. And so the internet and, the website is sitting on a server and all these computers are accessing it. And in the case of a currency, that middle server would be the bank. And if the one computer wants to buy something from another computer, it goes through the bank first. Anytime you swipe your credit card, it's checking with the bank to make sure the funds are available, and then the funds are withdrawn and then give to the other person. So a decentralized system removes that. So we see on the right a peer-to-peer network where everybody can talk to everybody directly. So how would that work with a currency though? Because I could give $1,000 to one person and then give $1,000 to another person, but I only had 1,000, and I've just created a problem with the currency. And what Bitcoin does is every computer has a copy of the ledger, and the ledger is a record of every single transaction that's ever been made of Bitcoin, and currently that ledger is over 100 gigabytes large. Which also means anybody could get online to one of these websites storing the ledger and see every transaction. And if you have a Bitcoin wallet, it's like got a bunch of codes. And if you know somebody's Bitcoin wallet, you can search that. You can search that ledger by their code, and you'd find all their transactions. But what that does is, so I make a transaction with somebody and the ledger is updated for everyone, and so if I try to make the same transaction with someone else, they know that that's not valid. I don't have money anymore because I spent it already. So it's a little bit more complicated than that, but this is a very high level view so we can get on to blockchain. So what is a blockchain? So Bitcoin, the currency, is built on the Bitcoin blockchain. And what is widely called a blockchain is really a combination of three technologies. You got peer-to-peer networking, as I went over in the last slide. You got asymmetric cryptography and cryptographic hashing. And we don't need to get too much into those because that could go on forever, but just kind of a high-level view of what they are to understand blockchain. So what happens here is you've got a series of transactions, and then they're stored into a block, and then a new block is started, creating a chain of blocks. Each block stores a bunch of transactions, and the way hashing works is they use an algorithm that, based on the content of whatever it is you're hashing, it creates a unique code, which is often referred to as a fingerprint. So in the case of this block of transactions, a hash is created that's completely unique to it, and then a new block is started, and that block will have its own hash and also a link back to the previous block. So you've got one block linking to another block. And what that does is if someone was to hack block 52 and change the transaction to show that maybe money that changed hands was more or less than what actually happened, that would change the hash of the block, and now block 53 would no longer link to the correct block because the hashes don't match. That's how you verify that the blockchain is secure and it hasn't been hacked. It's one of the concepts that's going to keep coming up is trust, and that's how you can trust that everything is actually secure or everything is actually what it says it is. So this is used for like a currency, but there's a lot of things that sort of use this idea already. You know, like Google Drive, when you're editing a document, you can have multiple people at one time all editing a document. It has to have a way to ensure that my edits are seen on your page and your edits are seen on my page, even if we're both doing it simultaneously. So Ethereum is a very interesting technology, and it's part of the reason that I'm even talking about this. It's as far as I know, it's the first blockchain technology that was created solely for the purpose of blockchain apps, and it was designed by Vitalik Buterin, and he's a very interesting person. I encourage you to look him up. I'm going to include some videos. Guy's super smart. I think he's like 22 or something, and he made Ethereum when he was 18. It's ridiculous, but he's a great guy to listen to, and he really knows what he's talking about. But he created a blockchain framework. He calls it an open software platform. And there's a programming language built into it called Solidity. So you would actually program in Solidity, similar to how I would program in Java, or the Android version of Java if I'm making an Android app, or any of these other languages that will convert it to an Android app. But the idea is that you write your program and then it works in this platform. And it's Turing complete, which was a new concept to me when I started looking into this. But I had heard of Alan Turing and the Turing machine. He basically made the first computer, even though it technically wasn't a computer. But Alan Turing had a theory that you could create a machine that, given enough memory, could solve any problem. It doesn't need to know the inputs beforehand. It doesn't need to know what the output's supposed to be. It doesn't care. It can solve anything. So Ethereum is designed to be Turing complete in that it can do anything. It doesn't need to know what it is you're trying to do. It's completely open. And its reason for existing is to enable developers to build blockchain apps. There is a currency built on it similar to Bitcoin. It's called Ether. But Vitalik will talk about this if you watch any videos on him, and he'll say that Ether is a byproduct of Ethereum, but it's not the reason for Ethereum existing, as opposed to Bitcoin, where the Bitcoin blockchain exists solely to support the Bitcoin currency. And he's created an ecosystem with this where you could just have a bunch of apps all running on Ethereum. And he's got, once it scales, he works on the scalability problem. Then he imagines a day where you're playing online games and you're banking, you're doing everything on Ethereum. So trust, I told you this would come back up. Trust disrupted is what Vitalik calls it. But the idea is that you don't need to trust anymore. That's what blockchain is doing. So you think about the transaction that we were talking about before, and there's a lot of trust involved. When you go to vote, you're trusting that you're trusting the machine that you put it in, that the vote will get counted. And anytime you hear some news report that Russia might be hacking it or something, then you start to wonder if your vote counted. If everyone voted for one person, but then the other guy won, then you start to not trust the system. You think, well, what's going on? Is it rigged? And And it does this with a thing called smart contracts. And the idea of a smart contract is that you don't need to trust the other party. So if if I'm buying something from Amazon, I'm trusting Amazon that when I give them my money, they're going to ship it off. And then they're trusting, not necessarily me, well, they're trusting that I'm using an account that I actually own, I guess, to pay. But they're also trusting the bank that's tied to my account, that when they run the card, I put in my credit card info and they check it, they're trusting that check is accurate and that I do actually have the money, and that when it says we're going to pay you, they're going to actually get the money. So with a smart contract, you don't have to trust anymore. You set terms of a contract, and neither person pays in the case of currency, or it could be something else. You could be paying with something else if it's not currency, until all terms are met. And there are other blockchain ecosystems being developed. This is a huge deal. IBM's working on one. IBM, it's predicted that 15%, I think, was the number of all financial transactions will be done on blockchain. Banks are getting into it. Everybody's getting into it. This is a really big deal. Ethereum's the big one, though. That one's really exciting, especially when Putin announced that he was going to invest in it. The Russian government was going to invest in it. But then they finally decided to make their own. But Ethereum's a big deal. So we'll go over some of the things I think could really change what we do, and really the possibilities are endless. There's limitations to it. Obviously, you can't do everything. Sometimes you need a central body, like something may only work with a central system, but there's a lot of things that could be done better using a decentralized system like blockchain. One of them is voting / government. So voter registration. You don't have to question whether the person that voted actually exists, or if they're a dead person, or whatever all the scary conspiracy theories are. It's a valid vote. You don't have to question, if you're the voter, that your vote is being tallied and that it's being counted correctly, because you'll be able to see it. You can verify the identity of a voter, authenticity of votes. You could use it for storage of public documents. The country of Dubai has announced that they're going to store all public documents by 2020 using blockchain. Dispersing of public benefits. This is actually a really interesting possibility. So Social Security, food stamps, healthcare benefits. If you've got some prescription card to pay for your drugs or something, you could use blockchain to handle those transactions with smart contracts. If you're getting food money or social security payment, you could the body giving that payment out, in this case a government, could verify that it's going to the correct person, or that it's actually being used for what it's supposed to be used for. And then things like universal basic income is a hot topic that's coming up a lot lately. And with robots and autonomous cars and everything, people are worried that there could be a point where there just isn't work for everyone, and everyone's going to need some sort of basic income. And blockchain technology could be a really good way to handle that. Democracy Earth is a company working on this. There's a few of them. This one was really interesting to me. They call it open source politics, and I think they did it smart, that they're not shooting for the top, like toppling governments and having it completely replaced by a blockchain government. But they have an app called Sovereign, which they call it decentralized governance platform for small and large organizations. And you notice they call it small and large organizations, not governments. So the idea is that you could, just start a company that, maybe an employee-owned company. You and 20 friends and you manage the company using a blockchain app like Sovereign. I could see some small cities turning to something like this, and then eventually something bigger. Um, but it's really interesting, the possibilities. Now, obviously, the limitation of this is that to go real big, existing centralized systems like our governments would have to adopt it, so they have to voluntarily give up some power. So that's an obvious limitation, but it's still very interesting where this could go. So healthcare slash identity, included identity in here. There's a lot of people working on identity and healthcare using blockchain. But I think the core problem of healthcare really comes down to identity. And and it comes back to that: how often do you fill out the same thing over and over again on a form? So if I go to a military doctor and they check my teeth and they see I've got some sort of cavity or something, some other doctor doesn't know about that, or if say I've got some sort of blood condition that my doctor knows about, but then I pass out and then ambulance picks me up and they don't know about it, so they're treating me assuming I don't have it. It causes a lot of problems. And people have often talked about, oh, we need a database where all these hospitals can share information, but the question has always been, how do you do it? Each of these hospitals has their own storage, and it's all antiquated systems. They're all prone to hacking, and how do you fix that? How do you verify the information is the same? And how do you take a bunch of centralized systems and then share information between them? So blockchain is ingenious for something like this, to where the information gets updated once, and every healthcare body would be updated with that same information. They all have the same information, and you could, in theory, go to any hospital in the world, give them your information, pull it up. They'll be able to validate that it's actually you, and you will be able to validate that your information is secure and it wasn't tampered with. Somebody didn't hack in and change your blood type, and they'll know things that are important, and we'll be able to share patient information. But it goes further than that, and it solves. And this company Gem is really interesting, and one of the things that they're marketing their blockchain app for is for healthcare, but they're going bigger than that. They're looking at the identity problem in general, which I think is the core of the problem. So I took these images off their website, but in the top left there, you've got the red person there, and that's you, and each one of those silos is some organization or institution that you interact with, and with all of them you have a separate identity. You get insurance, you've got to fill it out, name, blah blah blah, all that stuff. You go open a new bank account, you've got to fill it all out, and they all have user information that they store. I'm sure a lot of people watching this have written apps and worked on large databases full of users, and they all have different ways that they store the information. But you have a different identity in theory with all these different organizations. So what if you could just have one identity, and it's stored in a blockchain, which you have there in the bottom right, and then you use that identity to interact with all these institutions, and it removes trust from both ends. So this hospital knows it's you, and you know that this hospital is getting the correct data and it's not being inputted wrong. Banks and medical and your driver's license, it really could be anything. It's really fascinating where this could go. So the last thing I want excuse me, last thing I want to go over is cloud storage. This is a really interesting one also. Yeah, and this goes broader to just how we store data in general. So the idea of cloud storage was supposed to solve the centralized data storage problem to begin with. So you've got all your data stored on a computer, and then if you lose that computer, you lose all your data. So put it in the cloud, right? You've now, your data is now decentralized, and you can log on from any computer and you have all your data. You've got operating systems like Chrome OS that don't store any local data. Everything's stored in the cloud. And in theory it works, but the data is still stored centrally. It's just synced among several different central storage areas, and depending on who you use, it might be one, might be two, could be lots, but in theory you could lose the data if it's only stored on one, or say it's stored in two locations and then both those locations get blown up. And it's also prone to hacking. Someone could hack in and change it, and there's no validation that the data is correct. So in a decentralized cloud storage, which I'm going to include links to some of these, a couple of them, they store your information among a network of computers, and it's similar to a Bitcoin ledger, to where every computer has the same information and everything's stored. And it's a history of data also. So if you change something, because everything's stored in blocks, if you change something, the changes are stored in a new block. So the entire history of that data is also stored. So anybody familiar with maybe something like Git could see how that could be useful. And it's also less prone to hacking because of the hashing and the way it's validates data between the blocks. So there are some questions on sustainability on that, because so if I have a Dropbox account and I stop paying them, they might store my data for a while, but then they say, hey, if you haven't paid us in a year, then we're just going to delete your information and make room for someone else. You technically can't do that with a blockchain data storage, because the nature of how blockchain works is you store everything and the entire history of it. So if I stopped paying my cloud storage provider, they can't just delete my data. They have to store it because it's part of the blockchain. So there's some questions on how sustainable that could be, because it's just going to keep getting bigger and bigger. But it's still some exciting possibilities with it. So there's a lot more to this, but those were the three areas that I thought were the most intriguing. Thank you for watching. I hope you found it valuable and you learned something, and I encourage you to check out some of the links I'm posting, especially the videos. So yeah, thanks a lot.